So I'm going to be talking about scientific measurements and basic algebraic problem solving in this video. I'm not going to spend a lot of time on scientific measurements, but there are a couple topics that I'd like to go over that students typically have some trouble with. The first thing that I'm going to do is go over the difference between the words property and unit. So to introduce the subject, I want to go ahead and show you 4 different measurements here. All right, 14 inches, 3 feet, 45 pounds, and 1.5 miles. All right, and what I want you to do is ask yourself, which one of these measurements here doesn't belong? All right, there's 3 of them that have something in common with each other. There's one of them that doesn't really fit in. All right, and hopefully you can figure out that the one that doesn't fit in is this one right here. Hopefully you notice that these 3 measurements here all describe how long something is, whereas 45 pounds describes how much something weighs. Another way of saying this is that all of these here are all describing the property of distance. Okay? 45 pounds is something that is describing the property of weight. Okay? Distance and weight are both considered properties. Okay? The words inches, feet, pounds, and miles are all considered units. Specifically, inches, feet, and miles are all units of the property which is called distance. So a way of saying this is that a property is what you're trying to measure. Something like, how long is it? How much does it weigh? How much time does it take for something to happen? But notice it doesn't say what unit you're trying to measure that property in. For instance, you can measure distance, which is a property, in either feet or inches. You can measure time, which is a property, in either the units of seconds or minutes or hours. All of these are examples of units which you're using to measure a property. So here's a chart of some commonly used properties, and this is definitely not a chart that contains all of the properties that there are out there. There are certainly a lot more properties, and we're going to be getting to more of those later. But these are some fairly common ones, properties that you probably have had some experience with in your life. And what I've done is put some units for that property along beside it, okay? If you're talking about time, I think everyone knows what time is. It's just how long something takes to occur. You can measure time in seconds, minutes, hours, days, or even years. There's probably some more units for that, but this is just a short list of it, all right? Distance, how far is it from here to there? You can measure it in inches, feet, yards, miles, and the one that you're going to have to become very familiar with, especially when we get to the metric system, is the unit meter, all right? Volume. Volume is how much 3-dimensional space something takes up, all right? Some units that you can use for that, pint, gallon, quart, and liter. And weight, all right? When you want to know how much does something weigh, you can either do it in ounces, pounds, or if you're talking about how much does, say a tractor trailer weigh, you can measure that in tons. One little way that you can cheat about whether something is a property or a unit is ask yourself, would the word sound fine if you put it after a number, all right? Does it make sense to say that something is 12 inches? Okay, sure. But would it make sense to say that the length of something was 12 distance? If you're talking about a unit, it's going to be something generally that you have a number in front of with the unit after it, all right? If it's a property, you would never be putting a number in front of it the same way that you would do for a unit. A very important concept about scientific measurements is that they always have a number and a unit. And the reason that I'm bringing this up is that a lot of times when we talk about measurements in our day-to-day life, we don't necessarily follow this rule. All right, let me give you a couple of examples of that. So here are a couple questions here that I want you to read and think about how you would answer. All right, first of all, how old are you? Depending on your age, I'm guessing that you would probably answer this with something like 16 or 17. How tall are you? If someone were to ask me that, I would say 5'10", all right? And if someone asked me what the temperature was outside, I would say something like 75. These are 3 different examples of why sometimes people have a hard time with this concept right here that you have to have a number and a unit. Okay, and that's because in a lot of common language, you assume that they know the units that you're talking about. All right, if you say, someone asks you how old you are and you say 16, you assume that they know that means 16 years old. All right, if I were to say that I'm 5'10", someone knows that that means I'm 5 feet 10 inches tall. And for the temperature, it would be 75 degrees Fahrenheit. But hopefully you recognize that when we're doing this, we're using a shortcut, and everyone does it, I do it. But when we're dealing with science, you're not allowed to do the same thing. All right? Anytime you give a measurement, you have to give both the number and the unit. You're not allowed to assume that the person either reading what you're writing or listening to what you're saying knows what unit that you're talking about. So the bottom line, if you were to have to answer this question, what is the temperature of the liquid? All right? If it's in this class, if you're dealing with some type of scientific measurement, you would have to answer it something like this. 45 degrees Celsius, all right? That has both a number and a unit, all right? If you just say the number without the unit, the measurement is meaningless. So